here we have to find the polar coordinates of the given point. And of course, this given point is in rectangular coordinates, a good old x and a y. But we're supposed to turn it into a polar point, which is an r and a theta. It does say to express the angle in degrees and then also in radians. And it says to use the smallest possible positive angle. Because remember, you could spin around in circles a bunch to have any number of possible infinite angles as an answer. So here we go. We got our x and our y. Let's actually kind of graph this point out so we can visualize it and see what we got going on. It goes to the right. In fact, let me graph it like this. It goes to the right a certain amount. What is that? 3 root 2? I don't even, what number is that? Crazy number, irrational. But then the y value goes up 5. Okay, so in fact, maybe I should just label it more like a triangle. I put this here like it was like on an axis, like on the scale. But really, maybe I should just move that over. It's actually just the side length. So let's just write it right here. 3 root 2. And of course, we're trying to turn it into an r and a theta. The r is the radius, and the theta is the angle. And so there we go. All we got to do is basically kind of solve this triangle. So the first thing is I'm going to find the r. The r is pretty easy. It's just some good old a squared plus b squared. I got to watch out. I got to wrap that. Equals c squared. So in fact, I'm going to wrap that as well, just so it looks like that. So a squared plus b squared equals c squared. Good old Pythagorean theorem. 5 squared, that's just 5 times 5, which is 25. But then this one, 3 square root of 2 squared, really that just means 3 square root of 2 times another 3 square root of 2. And of course, that actually just means it's 3 times 3, which is 9. But I have a root 2 times a root 2, which makes a normal 2. So I still got to do 9 times 2. So I got my 25 here. 9 times 2 is 18. And that all is going to equal my r squared. And so what? 25 plus 18 was that 30, 43. And that's my radius square. And so then we just got to square root it. And so the radius is going to be the square root of 43. We're not going to do plus or minus here. We actually, the radius is always going to be positive the way we're going to do it. I guess if we did a negative radius, we'd be shooting backwards. We're not going to do that. Let's just take the positive radius. So far, we got the positive radius for our answer. It's going to be the square root of 43, comma, and then what we really just need now is we need the let's see, let me try and get rid of, yeah, there we go. I'm trying to fix this number 4. My computer's lagging. There we go. Now we just need the angle, so theta. So let's figure out what theta is. To do that, we're going to have to do some inverse trig. They gave us the x and the y. Here we have the opposite and the opposite and the adjacent. So that's a good old tangent. So a tangent of this mystery angle is the opposite over the adjacent. Of course, we need to know the angle, so we got to do the tangent inverse of the 5 over 3 square root of 2. And especially if you type this in to like a normal calculator, just like a Texas Instrument, make sure we wrap both of these in parentheses so they're in the denominator of this fraction, that both of them are, not just the 3. So I'm actually going to fire up Desmos so I can type this in. And of course, Desmos does not default to degrees. Let's actually go degrees at first. So I'm going to go degrees. Make sure your calculator is in degrees. And in Desmos, I have to go to the functions, to the tangent inverse. And I'm going to do 5 over 3 square root of 2. Now notice Desmos makes it obvious that the 3 and the root 2 are on the denominator. If I need to, when in doubt, you can put parentheses around it just to make sure. But it looks like our angle is about 49.68. So I'm going to say 49.7, which is not a very good angle. So we'll talk about that in a little bit, but we just got to deal with it. This is not a very good problem. I just made it up. So the answer is 49.7 degrees. Okay, so 49, this is approximately 49.7 degrees. And so that would actually be my answer in degrees. So it would be 49.7 degrees. So here's the answer in degrees. Now we just need to write the answer in radians. I mean, really, the answer in radians is like the same thing, only we just got to convert that angle. So it's still going to be square root of 4 is the radius. Now we just need to put this crummy degree angle into a radian angle. And how do you do that? You just convert by multiplying by pi over 180. So I'm going to take this horrible number, which we have, 49.7 is our rounded version. We're going to multiply by the conversion factor of pi over 180. And so as a radian, that's 0.867 something. So I'll round this to like 2 decimal places now. So 0.87. So that would be my answer, 0.87. And those are radians because I didn't write a degree sign. So there's my answer in degrees and in radians. Let's do another problem here. Again, it says find the polar coordinates of the point. Express the answer in degrees and in radians. Remember, this is the x and this is the y. We're trying to turn it into an r and a theta. So if I draw my picture, this time actually I noticed I need more space over here because we're actually going this way. It's a negative x value, so we're going negative 4 there, and then we're going positive root 3 there. And so here's my triangle, not drawn to scale, and it's a right triangle. So we're looking for the r, the radius. We're also looking for theta. Now I'm going to put theta here, but technically the theta we want is the theta that gets us here. This is just the reference angle. So here we go. Let's try this out. First off, let's do good old Pythagorean theorem. A squared plus b squared equals c squared. Definitely need parentheses here with the negative. And I'll even do that, especially with the root. So a squared plus b squared equals c squared. Really, it's the x squared plus the y squared equals the r squared. Of course, this is just positive 16. You type it in a calculator wrong, it might lie to you and tell you negative 16, but you should know better than the calculator. And the square root of 3 squared is just regular 3. Root 3 times root 3 is a regular 3. It takes 2 to make a thing go right. So this is just 19. Well, r squared is 19. We need just regular r, which is the square root of 19. So there's our radius, square root of 19. And in fact, I can put that in sort of my answer here. So square root of 19. All we need is the angle, and we'll be good. To do that, again, we're going to have to do a tangent inverse. So we are going to do the tangent. I always like to think of the tangent version first, the normal way. Tangent is opposite over adjacent. Okay, so that means to find the angle, we are going to do the tangent inverse. That's, whoops, I forgot to write the negative 1 there. And there's our tangent inverse. So let's fire up Desmos to see what that is going to be. Tangent inverse of, and again, because I opened a new Desmos, let me make sure I'm in degrees. Let's go tangent inverse of the fraction with square root of 3 over negative 4. And it tells me the answer is negative 23.4-ish. So let me write that down, negative 23.4. And then we'll see why it gave me that. It's about negative 23.4 degrees. Okay, it gave me negative because negative would actually be here in this quadrant, but that's not what I want. The reason why the inverse gave me that is because the inverse is doing all students take calculus. Tangent is negative in this quadrant, and this is the quadrant we keep for the tangent inverse. We actually want to be in quadrant 2, which is also a negative quadrant for tangent, but the inverse gets rid of that. So we need to somehow convert that. Of course, that means this is a 23.4 degree reference angle, which means this is also a 23.4 reference angle. So this 23.4 is just the reference angle. We need the angle that actually gets us into quadrant 2. So we actually just need to do 180 degrees minus 23.4 degrees. What is that going to be? 156.6, is that right? Just kind of doing some mental math here. 50, 60, 70 with a 9 and carry. Yep, so that looks right. So that's actually our angle. Our angle that we want, in fact, let's give myself some more room. It's a pretty big angle. 156.6 degrees. In fact, notice it says using the smallest possible positive angle. This is a negative angle. In fact, it's in the wrong quadrant. It's the wrong point. But we don't want to also go negative this way. That would be too much. In fact, we don't want to spin around a bunch and then get there. We just want the most direct positive angle, which is what we just did over here to figure it out. So actually, there's our answer in degrees. We just need to convert this now to radians. Okay, and again, our radius is not going to change. The only thing that's going to change is the angle will convert to degrees, from degrees to radians. So let's see what that would be. Remember, to convert from degrees to radians, this is degrees, you're going to multiply by pi over 180. Remember, we have degrees right now. We want degrees to go away. So you put degrees on bottom. So let's actually fire up Desmos and do this, this conversion. So let's see. We have 156.6, and we need to multiply by the fraction of pi over 180. So it looks like we get 2.73. Let's call that it, 2.73. So 2.73, and that's the radians. Notice we had really bad degree angles, so we got really bad radian angles. I actually have a bonus question for us, because what would it be like if we had a nice angle? And let's see, allegedly this is going to be a nice angle. Let's see if it is. Again, we're converting this, I didn't write the directions here, but this is a rectangular point, an X and a Y. I want us to convert this into a polar, an R and a theta. So real quick, let's just draw this this picture. And again, if I look at the numbers, I can tell that we're actually quadrant 2 again. So we're actually going to go -3 over here, and then +3 root 3 over here. Of course, we want to find the R and the theta. All right, let's quickly find the R, although that's not the focus of this bonus question, because what I want to talk about is what if the angle is good. So let's just quickly find this. A squared plus B squared equals C squared. Of course, this is 9. This would be 3 squared, which is 9, but the root 3 squared is just a normal 3. And so together the 9 and the normal 3 make 27. And so what's our radius square? Our radius square, if we put these together, was at 36. Oh, look, how nice. Square root both sides. This has a nice radius. The radius is 6. I wonder if the angle is nice. Here's what I should notice. Instead of doing, well, actually, I was going to say, instead of doing the tangent inverse, I can still do the tangent inverse, but I might notice something here. It's -3, 6, and 3 root 3. Notice something about all these? They all have a 3 in common. I can divide everything by 3. And this is just a larger version of a classic triangle, which is a 1, 2, and square root of 3. That's a famous triangle. In fact, let me draw the axes here, because we're still in quadrant 2, and that's important when you're dealing with angles. This is actually a 60-degree reference angle, which means it's actually 120 degrees to get me into quadrant 2. Of course, if we just did the tangent inverse of the opposite over the adjacent, if you just did the tangent inverse of this, guess what you'd get? You would get, actually you'd get -60 degrees, because remember, all students take calculus. The tangent inverse is going to give you a quadrant 4 answer, -60, but that just means this is 60 degrees here in quadrant 2, which is a 120 degree actual angle as opposed to the 60 degree reference angle. So what we now know is the angle is actually 120 degrees, and that's a nice angle. So in degrees for our polar form, we got 6, 120 degrees. Of course, in radians, that would be 6, well, do you know what 120 degrees is in radians? You can convert. you could go 120 times the pi over 180, or if you're really slick, I actually think it's quicker to just realize that 60 degrees is pi over 3. And of course, we don't want pi over 3 though. We're actually wanting the amount of angle to get us over here with a reference angle of pi over 3. Well, notice right here would be a full pi, 180 degrees, which is actually 3 pi over 3. But we're pi over 3 shy from a full pi. And so that would be a remaining of 2 pi over 3. This is 2/3 of pi because the reference angle is just 1/3 of pi. So that would actually be my radian answer. And that's actually a nice radian answer because it came out nice. We had a nice degree, so we got a nice radian answer. So there is how we can convert a rectangular point into polar coordinates.